almost more than 20, 25 years as a web developer, network engineer, uh, programmer, and so forth, and also done Python, JavaScript, you name it, Java, the whole 9 yard. And now I'm doing learning. And it's a very good area to get into if you like programming or like technology or like artificial intelligence that's taking over the world right now. So let's get into it. All right. All right. So what is machine learning? Machine learning is a powers some of the most important technologies we use, from translation apps to autonomous vehicles. This course explains the core concept of machine language learning. Okay, so uh, learning solves most of the complex questions that comes around in the world today. From when you're using your computer, you type in, and also all of a sudden it auto corrects, it auto suggests things to you. That's machine learning. Okay, that's sample of what machine learning is. Or when you're on your phone, you type in, and then all of a sudden auto suggests something for you and completes your sentence. Machine learning. Okay, so that's just sample of what is going on. In basic terms, machine learning is a process of training a piece of software called a module to make useful prediction of or generate content from data. Okay, suppose we wanted to create an app to predict rainfalls. We could use other traditional approach as by creating a whole bunch of apps, getting all the data into a database. But with machine language, all you have to do is just get a whole bunch of data and put it into the database, and you create the software, and the software automatically start learning what you have in the database and predict its own intelligence, make its own decisions. Okay, using machine language approach, we could give a machine language model enormous amount of data, weather data, into the machine language model eventually learns the mathematical relationship between weather patterns that produce different amounts of rain, and it gives out the correct amount and predicts the amount of rain that it needs to do. Instead of you sitting there trying to type in all this different variation of what the outcome should be. Machine learning will learn everything that you put inside of the database and automatically come up with the right decision for you. Right? It's not always correct. It only takes in what input that you put in and brings it out. So you have to put in some good information in there and correct information to get the correct information out. Right? Just take an instant for like Wikipedia. All the information in Wikipedia, there's a whole bunch of information in Wikipedia. Some are not true, some are true, right? So you have to decipher yourself which one is true or not. The same with machine language learning. So if the data is in there, it's not good, you're getting false information. Okay? Terms to know: training, module, and prediction. Training is the process of determining the ideal parameters, like weights and whatever parameters you have for that application or whatever you want to get out. A module in general, any mathematical construct that processes input data and returns output. Okay, so you have a model, whatever you put into it returns the output of it. So input, output. Like I said before, what do you put inside of it? If it's correct information, will give you the correct output. Okay, so you have, please, this differentially, a model is a set of parameters and structure needed for a system to make predictions. In supervised machine language, a model takes an example as input and infers prediction as input. Which supervised Within supervised machine learning, modules differ somewhat. Okay, so like I said before, input and output. Whatever you put in, get you the right output. Predictions and model output, for example, prediction of a binary classification model is either positive class or the negative class. The prediction of a multiple class classification model is one class. The prediction of linear regression model is a number. Okay, we'll go over all this as we go along with the training. Okay. So just keep in mind training, module, and prediction. Those are the main things that you need to know. Okay. If I'm going too fast, please let me know. Elizabeth, if I'm going too fast, let me know, please. There's types of machine learning systems. Machine learning system falls into one or more of the following categories based on how they learn to make prediction or generate content. There's supervised learning, unsupervised learning, reinforcement learning, and generative AI learning. Okay, so we'll go through each one of them and we'll give examples of each one of them, and also we'll have a quiz after we finish each one of them. Okay. Supervised learning. Supervised learning models can make predictions after seeing lots of data with the correct answer and then discovering the connection between the elements and the data that produce the correct answers. So supervised learning is you put all the information in there and you get the correct answer to that instant. Okay? So say for instance, you have it like what are fruits? You give apple, uh, broccoli, bananas. What is that? Another vegetable? Uh, Lettuce, tomatoes, mm, and celery and stuff like that. So the answers are, bananas, oranges, and tomatoes. Those are fruits. So you give those answers to the supervised learning module. So you feed it a whole bunch of information, and then you give the answer to it. Okay, that's the supervised learning portion of the machine learning. Two of the most common use for supervised learning are regression and classification. We'll go into that also. Click. Regression. A regression module predicts a numerical value. For example, a weather module that predicts the amount of rain in inches or millimeters is a regression module. See the table below, for example. I don't know if you see it because it's kind of small on screen, but we have scenario, we have possible input data and numeric prediction here. So we have the future, house price, future, what is it? Future price and future time. And then you have possible input data about the house pricing and the numeric value for it. It's just regression. So you have something, you're putting something in there, and then you're saying that at the end, you get a future output for it. Okay. So you something right now, and then in the future, you get something output out of it. Okay. So you are putting the information inside of it, and you're predicting the future, which will come out of it. This is a regression. Okay. Then we get classification. Classification modules predict the likelihood that something belongs to a category. Unlike regressive models, whose output is a number, classification model outputs a value that states whether or not something belongs to a particular category. For example, classification models are used to predict if an email is spam or if a photo contains a cat. That's just an example. Okay. All right. So regression outputs a number. All right. And classification outputs a value that states whether something belongs to a particular category. So you classify that scenario. Okay. So let's say, for instance, you go to the store, you're going to buy something. It has a price to it. So that's a regression. So if you pick up the banana, it says 50 cents per pound. So when you go to the checkout, you put it on the thing. Automatically, when you put it on there, it weighs it, and then the machine gives you a price. That's regression. Okay. At the same time, when you pick up that banana, there's a classification part of it in the system saying this banana belongs to the fruit category in the produce category. Okay, so everything's tied together. So the machine, when you go and scan it, boop, it says, "Oh, this belongs to the produce department." right? And you put it on the weight. Oh, regression. This thing weighs this much and it costs this much. This how much you have to pay. Okay, so I hope that gives you a understanding for those 2 points. Unsupervised learning. Unsupervised learning is when makes prediction by being given data that does not contain any correct answers. Okay, so I'm giving you a whole bunch of data, and then the machine itself will come up with the solution for it. Okay, so if, for instance, you have a little baby, okay, and the baby starts walking, and you say, okay, you just leave the baby there. The baby starts moving around, doing everything it needs to do. It picks up the toy, puts this inside of there, walks around some more, just pushing things around, pushing stuff around. After a while, the machine will figure out, okay, the baby walks around, picks up the toy, puts it into here, then comes back, pushes these things around, and then pushes it out again and picks it up and puts it in there. So it's learning by itself without you giving it answers. That's unsupervised learning. Okay. So before, supervised learning is, I'm gonna tell the baby gonna push this thing down, pick up the information and the stuff, and then put it back into the basket. So you tell the machine what it's gonna be doing and what's gonna be done. That's supervised learning. Unsupervised learning is you just let the baby do whatever it's doing, and the machine's watching the baby, and it predicts what the baby's gonna do. Okay. Just giving you the idea, a little scenario. All right. And just another scenario is like when you're driving around, you go from school, you're going from home to work. You know the route. Every day you do the same route, right? So your brain automatically learns. It's unsupervised learning automatically, right? Because you're doing it every day. So you're learning it. But supervised learning is when you use the GPS. The GPS says go here, turn right, turn left, right? That's supervised. It's supervising you where you need to go to. But if you don't use the GPS and you do it yourself, you're learning by yourself and you're predicting the outcome of it. Okay. So remember, machine language utilizes everything that the body uses, just like a human being. Okay. You learn as you go, or go through life, or do something new. Okay. Unless you already know somebody already did it and you know the outcome of it, that's been supervised already. So your outcome, you know what the outcome is. But if you're doing something new, that's unsupervised learning. You're learning newly, and then you also come up with your own prediction. Okay, that's the same thing they do for the machines. Okay, I hope that makes sense. All right, we have here. All right, let me say this. Okay, a common use unsupervised learning module employs a technique called clustering. The model finds data points that demonstrate natural groupings. Okay, it's like I was saying before, the machine, it takes everything in cluster. Let's say in cluster. So when you put the machine in a different room, it learns that room environment. So a different cluster, whatever's going on in there, it start learning. You take that out and put it into a different machine a room, it start learning different clusters, the different techniques. So you can call this as clustering. Okay, this is just technique of it. So you have cluster one, an ML model clustering similar data points. So you have one cluster here, another cluster, another cluster. So it's learning. Eventually, it'll learn all the cluster and come up with its own, what do you call it, solution. So if you got it here, grouping of clusters. So you group the cluster one, cluster two, cluster three. So this one's all over the place. But eventually, you can cluster them into different data sets. So you can pinpoint uh, more efficiently and more precisely. Okay, this one, when you're going around, you might run into this cluster two or cluster three, so it might mess up the data a little bit. But if you cluster them into cluster different groups, it makes it easier to predict if you're in cluster one, cluster two, or cluster three. I hope that makes sense a little bit. Okay. If I'm going too fast, let me know. Elizabeth, let me know if I'm going too fast. All right. All right, clustering differs from classification because the categories are undefined by you, like I was saying. Okay, so the machine learns different cluster. You can't define it. It will define it by itself after uh, what's called analyze the data, and it comes up with its own conclusion. For example, an unsupervised model might cluster a weather data set based on temperature, revealing segmentation that define the seasons. You might then attempt to name those clusters based on your understanding of the data set. So let's say the seasons here, okay? You have all this different weather. We have summer, spring, fall, and winter, so forth. All right. So if you have the machines there learning everything, then you can group them together into different type of data set. Say for instance, you have the snow, you have sleet, rain, and other parts of it. Okay, during the winter time. Okay. So with this one, it sees everything. But once you cluster it and define it, it makes it easier for the machine to learn quicker. This one takes a little longer. This one makes it quicker for it because you can define the cluster for it, and it can predict the the temperature, how much is going to rain, how much is going to sleet, and so forth. With all this information. Okay. Reinforcement learning. Reinforcement learning module makes prediction by getting rewards or penalties based on action performed within an environment. A reinforcement learning system generates a policy that defines the best strategy for getting the most rewards. Reinforcement learning is used to train robots to perform tasks like walking around a room and software programs like iRobot to sweep your house. Okay. So reinforcement, say just like a kid, if they do a good job, or you give them something, money for washing the dishes or clean their room, reinforcement, right? If they do something bad, you go to timeout and sit there until you think about what you did and learn your lesson. The same with the machine learning. You can do it in reinforcement learning. If they do something wrong, say no, that's timeout. That's not right, and then they learn from their mistakes. Just like I gave an example of iRobot. When it's running around your room and it bumps into the wall, it backs up and it bumps it again. Second, and then comes back second time. They say, okay, I learned this is a wall right here. It puts into this database, then goes around, right? Remember, iRobot, as it going through your house, is scanning everything in your house and keeps you into that database to learn the parameters of your house, up in the feet and the squarage and everything around your house into the database. Okay, that's reinforcement learning. So once it hits the wall, it said, "No, this I can't go this far, and I will hit the wall. I can't go that far," and it goes back. Yeah, just I like to use human beings. A baby, he's falling on the floor, going really fast. Then he hits something, boom, comes back. Oh, my head hurts. I should not do that again. Then they stop doing it. He won't do it again, right? That's the same way the machines learn the stuff by reinforcement learning. This is reinforcement learning. You not tell them anything like in supervised learning. No, it's reinforcement. They do it by themselves. When they hit something, they learn it themselves. And you say, "Oh, good job. You didn't hit your head this time. Good job." If you hit your head, that's not good. Try it again. Reinforcement learning. Okay. Generative IA learning. So generative artificial intelligence is a class of modules that creates content from user input. For example, generative IA can create new and novel images, music composition, and jokes. It can summarize article, explain how to perform a task, or edit a photo. All right. This type of, everybody's been hearing about chat GPT, chat, all this, all that stuff. Okay. This is a generative artificial intelligence. That means that it's garbage, the internet, everything that everybody has done in the whole world, it has access to it. Okay, that's what this AI is. Okay, so if you type something into the chat, let's say Chat GPT, you type something to Chat GPT, it doesn't know. It will tell you it doesn't know. But what you type in, it stores what you type in. Okay, then what's going to happen is the people that's developing this AI will read that sentence that you type in and find out what the information is and answer it for him. So next time you come back, it knows the answer that you have done. Okay, or what it does is reinforcement. It'll go through the internet as much as it can to find the answer. If you can't find it, they'll tell you, "Oh, I'm sorry, I can't find it." Okay, or what it will do is to get the answer from you, it'll give you a different answer, right? And when they give you a different answer, you sitting there, oh, that's not right, Chat GTP. This is the correct answer. Da, 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 da. Right? So that's you gave him the answer. So okay, thank you very much, Peter. The next time somebody asks the same question, oh, I know this answer, and give it to you. Okay. So like I said before, what you put in is what you get out. Okay. So if everybody's putting the same answers I'm putting in before, it'll give the same answer. But once you start putting in different answers for everybody, it'll start doing its own reasoning to come up with the answer for you. All right. So remember, the AI, Chat GPT, all that stuff, everybody's happy with it. Is also learning everything that everybody's doing everything that's people, even from, let's put it this way, your iRobot, all the information that you've taken goes to a certain centralized place. ChatGPT has access to it. So ChatGPT has access to how big your house is, how far you sleep, wherever it is. All your cameras that you put on your door, your ring bell, and all that stuff. It goes to a centralized place. ChatGPT has that access to that too. So it knows when you're sleeping, or the iPhone that you wear, your temperature on your arm saying this guy ran 20 miles per hour, his heartbeat is this, blah, blah, blah. It goes to a centralized database. ChatGPT has that information too. Remember, everything that you have, all the wearable, everything that you put in your ear, everything goes to a centralized database. And everybody, the ChatGPT or AI has access to it. Okay? That's why I tell everybody, be careful what information you get put out there. Your phone, everything you put it down is listen to everything you say. ChatGPT had access to it. You turn it off, it's still on. You got to take the battery out before it takes 3 hours before the battery, the CP moss dies inside of it. So when you take the battery out, it's still on for 3-4 hours. Okay, I'm not trying to scare you, but that's the thing of it. Okay, so everything that you do, everything's recorded. So Chat GPT or all these AI folks, they know everything about what you're doing. Okay, that's generative AI learning. All right, we can discuss generative models by their inputs and output, typical rating as type of input to type of output. For example, the following is a partial list of some input and output for generative models: text to text, text to image. So if I type in the text saying flower, they can generate image of a flower like Chat GPT does right now. And you can see text to video. Oh, give me a flower waving in the sun. It will generate a flower, a video of it with the flower going waving in the sun and so forth for you. And you can text to code. So if you're writing a code or doing a Python or HTML or JavaScript and you don't know what to do, just go to one of these AI and say, oh, please help me out. I'm stuck at this. Give me the code for so and so so, and it will generate the code for you. Okay. And also text to speech. If you type in the text in one, like for the disabled, not disabled, but people can't see but can hear very well, they can press a button and then they can type in the braille, they type in the braille, and it talks through the machine for them. That's text to speech. Okay. And then image to text to image, the same thing. You snap in the image, it automatically converts to the text for you. Okay. So there's a lot of things generative AI learning does. This one is more powerful because it's covers the whole internet and finds everything for you. But at the same time, it doesn't happen by itself. You have to program it. Okay, somebody has to sit there and program it. Right? That's why the engineer comes in, the machine language engineer comes in to program these things. But after a while, the machine starts learning itself and all stuff. After a while, all you're doing is inputting new stuff that's coming out for it. Then after a while, the machine takes over everything. I'm not trying to scare you, but the machine's gonna be taking over soon. Terminator's coming in. Sorry. This other stuff. The following table lists an example of generative models, the input, and the examples. All right. I don't know if is it too small on the screen here? Or it's okay. All right, this is the examples I just gave you. All right. All right, generative AI learning. How does generative work? At a high level, generative model learn patterns is data with the goal to produce new but similar data. Generative models are like the following. Communities who learn to imitate others by observing people's behavior and style of speaking. Yes, we have generative AI now that can imitate anybody's voice, anybody's character. Just take a picture of somebody, and the picture start talking with a person's voice, the same mannerism, the same everything. Okay, and that's very scary because now you don't even know what's going on. I heard on the news 2 days ago that some ladies, what somebody called a lady, and it was using her kid's voice, saying that she was in trouble, that they need $2 million if they don't give that money to that person, or she'll be in trouble. But he was using the lady's kid's voice. But meanwhile, the lady kid was in the room upstairs. And she's like, wow, how does that happen? It sounded just like her, the same mannerism. Even when she asked, how you doing? The voice answered back just like the kid answered back. So this is getting crazy out there. All right, another one, artists who learn to paint in a particular style for studying lots of painting in that style. That's going outside the window now. You can just go in and ask one of the AI, paint me a Picasso painting. And it paints you painting just like Picasso. And you can't even tell the difference. And it's so real. So you can never tell what's going on right now. All right, cover bands that learn to sound like a specific music group by listening to a lot of music by that group. Okay, so I like reggae, so I can say make me something like Bob Marley, and Bob Marley will start singing to me and sounding just like Bob Marley, the same tone, everything. You can't tell the difference. Okay, that's how generative AI is is going, and it's moving very quickly. Chat GTP was just is old. There's new ones out there that's just really astounding. They can make you a video. They can make you music in faster than ChatGPT nowadays. So the technology is moving very fast. All right. We have a quiz for right now. All right. So let's quiz to test your understanding so far. It's the first one. What is a module machine? I can't even see myself. What is a module learning? No, I can't even see myself. I'm sorry, Elizabeth. What is a module in machine learning? A. The module is a mathematical relationship uh, derived from data that an ML system uses to make a prediction. A module is a small representation of the thing you're studying. A module is a piece of computer hardware. What do you all think?
You can type your answers in the chat.
Yes, please. I can't see the chat, but I hope everybody's typing. Are they typing, Elizabeth?
Yes, they are.
Okay, good.
Everyone chose one.
Everybody chose one.
Yeah. Okay.
All right.
Charmaine chose two.
Okay. All right. So the answer is number one. Good job. So module is when you put something into for the machine language to start studying it, and it derives its own data and its own prediction from that data. Okay, that's right. So module is a mathematical relationship derived from data that an ML system used to make predictions. Good job, everybody. Let's go to the next one. All right. If you wanted to use it, ML module to predict energy usage for commercial building, what type of model would you use? Classification or regression? Type in your answer.
Yeah, everyone is picking regression. Yeah, good. Great
Good
job.
job. All right. So regression is the right one because it uses number. When a number output, that's regression. Okay. Classification is just the class of what the thing is. All right. Regression gives out a number output of a number. Okay. Good job, everyone. Question number 3. What distinguishes a supervised approach from an unsupervised approach? A supervised approach typically uses clustering. An unsupervised approach knows how to label cluster of data. A supervised approach is given data that contains the correct answer.
So they're choosing C. Two people chose C. Okay,
All
three.
right,
Yeah.
that's correct. A supervised given data that contains the correct answer. Yes. Supervised, you give all the data for the supervised, and then you give them the correct answer. That's supervised. Good job, everyone. All right, next one is supervised learning. Supervised learning is the dominant system at Google. Okay, so Google is the forefront of this so far. They have BART, their AI just competition to Chat GPT, right? And BART is more, how do you say it? More smarter than Chat GTP. I can't get it. Chat GPT because Google, remember, Google runs everything in the world. Google has all the data of everything in the world. Okay, and I don't know if you heard of Watson. IBM Watson is also an AI that's been around in the 60s since the 60s. So Google's tied into Watson, and Watson's tied into Google. So everything's tied in together. They're the biggest. So Google runs everything. If you think you're going to DuckDuckGo or Bing or everything, they run in the same database. Okay, so they just give them a choice where everything's coming from the same place. Okay, just let you know. All right. So we supervise is what is used nowadays. Everything that you have is given an answer already. If the answer is not there, they will find an answer and put into the database. Right. But this is just this is old information because the machine is learning stuff already by itself now. And it's been doing for a long time. These are new information they've been putting inside of it. So that's why they're using supervised learning, new information. But everything that you need to know in the world, they already know it, everything already. Okay. Now, supervised learning is the dominant ML system at Google. We know that. And that's connected to everything in the world, all the search engines in the world. Because supervised learning tasks are well defined, like identifying spam or predicting precipitation. Precipitation. It has more potential use case than unsupervised learning. When compared with reinforcement learning, supervised learning better utilize historical data. Like I was saying, historical, right? So Watson has all the historical data back from the 1800s, all back then, and it's tied all into the Google framework. They said Google started in the 90s. No, Google's been having access to Watson ever since then. Google just came on in after IBM broke off and established Google. No, everybody thinks Google just came out. No, IBM is back by it, right? To do the search engine and stuff for you. So everything that you type in when you type in what car is the best, what car maker is the best in the world, right? The answer is already there. If it's not there, whatever you type in will be the answer will be found and put into a database the next time you come in. Okay, that's why you have Google ranking. So what people you see people go there, people typing all that stuff, it has a ranking. So we have all everything that people are searching for at the top. Oh, a lot of people searching for this. A lot of people searching for this. So they put it into their database saying this is the most popular people looking for. Right. That's what makes Google so the top because they keep the database of everything that people searching every day and puts it inside there. Okay. Fundament fund I can't pronounce that. Foundational supervised learning concept. Machine learning is based on the following core concept: data, module, training, evaluating interference. All right, inference. Sorry, English is not my first language, so please. All right, so we'll go over all this, but remember, supervised learning is the key to what is going on right now. Even though the machine learning at the back end is doing its own unsupervised learning. Okay, so if you start using Chat GPT and the other AI stuff, you'll learn that when you type it in and going deeper, the machine start talking to you like a human being. It start talking like it knows what you're talking and even predicts what you're thinking before you start asking stuff. Okay, because what happens is everything that you're typing in, everything that's all the devices that's around you, everything's been picked up and amplified into the database. So it checks your surrounding for everything, the cameras, everything, your Wi-Fi, everything connected to your TV, connected to your smart home, everything's already transferred into there. So when you start typing and asking all these questions, it starts scanning everything in your house, your phone, everything to find out what you're looking for before you start asking for it. Have you ever wondered how you start thinking of something and then it pops up on your phone? Yes, I know people wonder about that, right? Because it's listen to everything you do, even when you think it. It's listen to your brain waves because remember your brain waves sends out signal. Everything's a frequency. It listens to it. Okay, it's not sci-fi anymore. This is real life. Okay, supervised learning data. Data is a driving force of machine language. Data comes in the form of words and numbers stored in tables or as a value of pixels and waveforms captured in images and audio files. We store related data in data sets. For example, we might have a data set of the following: images of cat, housing prices, weather information, and so forth. Okay, so for this one, numbers stored in data tables or the values of pixels and waveforms captured in images and audio files. So for now, some people, like if you want to send something secretive, you can store that information into pictures. That's called as a stencilographic or something technology. You store that information into pictures, into an image, right? So you put that in the image, send it over to somebody else. Somebody will decode it and find out what's written into that form for you. Okay, you can send it into audio. Even the songs. Nowadays songs have messages in it. When you play slowly, you learn there's other voices in the background telling you stuff to get into your subconscious, right? You can store information into that too. Okay, so that's supervised learning. So whatever you want to move out or do, you put that in there and you give the answer to it. That's a supervised learning. Okay, so you have images of cats. People love cats. I just have no idea why people love cats so much. Anyway, people will sit there and watch images of cats every day. Watch cats doing crazy stuff. If you're a cat lover, I'm sorry, but I just don't see the fascination about it. But anyway, people sit there and watch cats daily. So if you want to send messages in your cats, you can have your cat doing something. Only certain people can understand what the cat is doing because the cat lovers, they know their cat's better, right? So you can do the supervise, tell the cat to do something, and they'll send a signal to somebody else who's watching that cat and know what the cat is doing. Supervised learning. You train the cat to send out a message. Okay? Just give an example. All right? And then we have weather information. The weather, they predict the weather. How can you predict the weather? Every day they tell you what the weather's going to be. So that means they're controlling the information for the weather, right? So that means they have all the information about weather passed back to the way back, all the data about it, and will know what's going to happen to the same day or the next day or so forth. Okay, so they already have the data for it. Okay, just like supervised learning, they got all the data, put all data into the database, and they tell you what temperature is going to be because they'll also tells you last year it was 98 degrees. Today we predict will be 98 degrees or higher, and true to be it is 98 degrees or higher. Right? That's supervised learning because you already know it, they know the answer to it, right? And also, they tell you, the stock markets, the same thing. Everything's all market, everything's predicted, everything they know what is going to happen, right? And then you coming in, if you don't know this type of data, you'll be like, oh wow, this is so fascinating. But no, this is not. This has always been predicted, ever been done. And then most people go into the stock market. Oh, today I'm gonna make a lot of money, and they lose their money. But they didn't study the data that's already been stored out for all this the day and every day in, right? So you have to do your research. That's just an example also. Okay. All right. We have supervised learning data. Example that contains both features and a label are called label examples. So two labels, you have to the features here with the information, and then you have to label is the answer for the information. Okay, so we have the example that contains both features and label called label example. Okay, so all the information, and then you give it the answer. That's the label. The label is the answer. Okay. In contrast, unlabeled example contains features but no label. After you create a module, the model predicts the label from the feature. Okay, so you give all the information here, but there's no label because you're not giving it the answer. This is supervised learning. You're still giving them information, but no answer. So it's a form of unsupervised learning. But at the same time, you're giving the information to it. I hope you understand. Okay. Then of course, data set is a characterized by its size. Okay, the data set is characterized by its size and diversity. Size indicates the number of examples. Diversity indicates the range those example covers. Good data sets are both large and highly diverse. All right, so it's good to give something if you're doing a data or training. Give as much information and as much diversity for that training that you want it to be. That makes it more accurate and more positive answer for the person to get. All right. For instance, a data set might contain 100 years worth of data, but only for the month of July. That does not make sense, right? You can have thousands of data, but it's only for July. So I'm not going to make a prediction for the whole year. I only have data for the July, so I can only make prediction for July. So if you ask me something about November, I won't be able to tell you. I'm like, I don't know. All I know is July, right? So the best thing to do is give as much data for all the months. This is in terms of temperature and so forth. So we can do it from January all the way to December, and in January give as much as possible all through the whole month. Give as much data and as much diverse information you can to predict the weather for each day and for each month. So sorry. Okay. So I like to use human beings. So let's say, for instance, you have a little kid. You want the little kid to become a medical doctor. You want him to become an engineer. All right. So when he's growing up, you have a medical book laying here. So he sees it every day. You read in medical journals every day. You make him watch the medical channel every day. So you are given the data set to train him to become a medical doctor that you want him in the future, right? So you give him all the information that he needs to push him to become a medical doctor, right? The same thing that's here, okay? So it doesn't mean he's going to be a medical doctor, but he might become a medical doctor because he sees all this thing all the time, right? And he read into him, and one day you ask him something, he knows everything because that's what you've been feeding him. But it doesn't say that he's going to become a medical doctor, right? I had that experience myself, so I was fed to become a biomedical engineer, but I didn't want to do that anyway. So I became a computer programmer instead. So so that's how it is. Okay.
Yeah.
The module is supervised learning. In a supervised learning, a model is a complex connection of numbers that define the mathematical relationship from specific input feature patterns to specific output label values. The model discovers these patterns through training, like we said before. So you push in all this data to it, and you training the machine learning, the machine or whatever, whoever the subject is, to come out with the pattern and the answer that you want that person to have. Okay. Training. Before a supervised model can make prediction, it must be trained. Yes. How can all right, let's put this training. Okay. To become a soldier, you just can't wake up one day and say, I'm a soldier. That doesn't work. Here, if you want to become a soldier, or anywhere in the world to become a soldier, you have to go for training. You have to go to boot camp. You have to learn how to shoot. You have to learn how to swim. You have to learn how to survive in the world, in the wilderness. Okay. The same thing. If you want something to learn something, machine to learn something, you have to train it with all the information, right? Before a supervised model can make a prediction, it must be trained. So you have to train and train and train to make sure it understands how to survive and how to predict the stuff that you want it to predict. Okay. So training is key. So set up a module, then training, and then you evaluate. The evaluate is coming up next, and see how the person is doing or the machine is doing. Right. The module finds the best solution by comparing its predictive value to the label's actual value. Based on the difference between the predicted and actual value defined as the laws, the module gradually update its solution. So reinforcement again. Something happens, you reinforce it, and then balance it out. Okay, if it's down, you figure it out and balance it out. So it's always have to be balanced, so the machine doesn't get out of hand. So there must be a little balance with everything. Just like in the training boot camp, the drill sergeant is always here at the top. Then all of a sudden, everything's balanced because they start learning the same thing. Okay, this guy can't get unless he goes to a specialized school. Then he leaves the boot camp and goes somewhere else, right? But drill sergeants still always high until the cadets come in and they start training and become the same. Okay, the drill sergeant is still all the information to them to learn exactly what they need to learn, right? Just like a kid in the house. You have a kid in the house, you train them in the best way you can to survive on their own once they leave their nest or leave home. Even though you're your mother or the father, you always come back for advice, because they need you. But you have to equip them and train them the best way to learn and live outside of your house. Right? The same thing. Everything works the same thing. If you think about it in terms of that. Okay. All right. Training a module. The following demonstrates training a module. The module takes in a single labeled example and it provides a prediction. All right. So I put in something in here, train the module, and I predict what's going to be coming. So this is the data, this is the outcome. Okay, that's the outcome I want, and I put it into a module, and then creates a prediction. Okay, an ML production module makes a prediction from a labeled example. All right, the module compares the predicted value with the actual value and updates its solution. Okay, so whatever value I put it inside here, the value is always changing, right, into the module. So the module is always updating it from the information given here. Is always updating the module and updating the prediction. Okay, so you put the data in, you know the answer. You put into the module predict the prediction. But when the data changes in here, the value changes. That's the value. It goes back to the module, and then different prediction comes in. All right. So the module is always changing because the information is always changing. Okay, everything doesn't stay the same. Just like a human being, we're always changing every day. We're seeing different things every day. We're growing every day. So the outcome is always changing. So the model is always changing. Right? We all know at the. Oh, sorry. Okay.
Yes.
Any questions?
Yeah. Thank you so much. I'm just trying to remind you of the time.
Okay.
It's past power
Oh,
time.
sorry. Fast. Okay. Sorry.
I
All right.
think we're good, but you can definitely round up. We
Okay.
can always continue. Yeah.
I'm going to round up because I just want to do one quiz for everybody first. Let's do one quiz and then we'll close up. All right. Predictive power. So I don't know if you can read all this here, but we have this. We have the make, the color, the miles, the height. Which one is this one? Make, model, length, can tire size, wheel bearing, weight in year, and then the price. All right. Which three features do you think are likely the greatest prediction for the car's price? All right. Okay. All right.
Some chose B, while one person chose the first answer.
Okay. Well, the answer is the answer is B. It's kind of small to see, but the B, the make, model, year, miles. Okay. The model and the year the car was produced and the mileage it goes will predict the price for you. Okay. The miles, gearbox, no, gearbox doesn't matter. The make, model, yes, and the miles, yes, but the gearbox doesn't matter. Okay. And the size, wheel doesn't matter. This one doesn't matter because it is these the model predicts how fast it goes, the size of the car, the size of the engine, and the year. If the year is newer, it costs more. The miles is the gas per mileage and so forth. So the B is the right answer. Good job, everybody. All right, so let me go to the end. I hope everybody enjoyed this little training. We'll continue again next time. And if anybody has questions, please let Elizabeth know, and then we can go from there and stop sharing.
Thank you so much. Thank you. It's been an honor to have you walk us through machine learning. Thank you.
Welcome.
This is really informative and very insightful. That I don't know if you can see from the chat. Look
Oh,
at the left side of your screen at the top, something that looks like a cloud.
yeah, I see it. I see the chat now.
Okay, yes. So everyone is thanking you. Everyone is excited. Thank you so much for this moment. And you shared your contact. You can put up, you can do, well, this is recorded. So that slide where your contact is, people will have access to it. You can also type it in the chat. And yes, for those who attended this session, you have access to the recorded video. Thank you so much. Thank you so much.